Hi everybody, today we'll do a little bit of a review on probability before we get into the grade 8 material. So this will be the grade 7 material review. Don't forget the probability basics are, it's usually a fraction, something like this. And on top on the fraction is what you want. So if you want green, then that would be only one green, so you don't want a 1. If you wanted green or orange, then there's 2 out of them are green or orange, so you'd have 2. And then the bottom number is how many outcomes are available. So in this case, when we have this spinner and we're going to spin it, then we would have a total of 4 colors that it could land on. So it could land on orange, or it could land on red, or it could land on blue. And so there's 4 outcomes total. So if we wanted to say, what are the odds of it landing on orange or green? That's the 2 on the top. And on the bottom is how many outcomes are there total. We can also do this with die, and so you can guess what number the die is going to land on, the outcomes that you want. So if we wanted it to land on a 4, you have to think about how many 4s are there on a die. There's only 1 of them, so that would be our numerator. And on the bottom, how many total outcomes available? If this is a 6-sided die, then all the outcomes available, there are 6 outcomes available, so we would have a 1 out of 6. And then of course we could change that to a percent by going top number divided by bottom number times 100. When 2 die are rolled, then we're getting into something called 2 independent events. And these are independent of each other because it doesn't matter what happens here, I can still get the result here. So if I roll a 4 here, I could still roll a 4 over here. It doesn't disappear. It's not like when you're picking cards. If you pick a card away, somebody takes it, and you say, now pick a card. If they have the Jack of Hearts, now you can't pick the Jack of Hearts because they already have it. In this case, one doesn't affect the other. So the same options are available. No matter what happens here, the same options are available here. So that is an independent event. When 2 dice are rolled, we have 2 independent events, and these can be shown in lots of different ways. And so what we're going to be doing is basically essentially rolling these die, right? Okay. So when we create these tables, we've got different ways that we can show all of the ways that this could happen. The rolling these 2 die. We have outcome table, organized list, tree diagram, and math equation. You can look at these first 3 in lesson 1 because it's a grade 7 review. So we're rolling 2 die. When we roll 2 die and we want to show all the results, we can create an outcome table. In an outcome table, across the top, you would list everything that happens with the first thing that you do. So first I'm going to roll this. When I roll this, here's all the ways that it could go down or could happen. It could land on a 1, it could land on a 2, it could land on a 3. There's my first roll, etc., all the way up to 6. After I roll the first die, I'm going to roll the second one. Okay? And when I roll the second one, it goes right here. 1, 2, 3, 4, 5, 6. So there's all the ways that it could go down for the second event. So this is first event, all the ways it could go down. In this case, a 6-sided die. And this is second event, all the ways it could go down. In this case, a 6-sided die. And what happens here is the result. So you rolled a 1 and you rolled a 1. When you add that up, you get 2. If you rolled a 6 first and a 6 second, you would have a total of 12, which you're probably aware of. So we can create an outcome table to show all of our results, which you will be doing. We can also do a probability tree. This one is probably my least favorite, because what you would do is you list everything that could happen in the first roll. So if you were to roll this die right here, if you were to roll it, it could land on, what's the lowest number it could land on? Yeah, 1, 2, 3, 4, 5, 6. There's all the things it could land on. For the second roll, this branches out for each. So it could also land on 1, 2, 3, 4, 5, 6. And you can see how this becomes monotonous because you would go 4, 5, 6, you'd list all of them. Right? All 1, 2, 3, 4, 5, 6. You list all these 3, 4, 5, 6. And you can see it does take up a lot of space. So there's actually a better way to do this than a probability tree. This does show all the ways it could happen, but it's not very organized. So we change this to an organized list. This is my favorite out of all the ways that if you have to show all of your work, this would be my favorite one. So in the first roll, what could it land on? 1, 2, 3, 4, 5, 6. In the second roll, what could it land on? 1, 2, 3, 4, 5, 6. And we would just do the same thing. So it does become monotonous writing it all out, which we are going to show a better way to do in lesson number 2. Now, this is all the ways that it could go down right here. So you got to think it's like, if we go back, all these 36 ways right here have been shown in a much tighter format. There's the 36 results. You could roll a 1, then a 1, or a 1, then a 2, or a 1, then a 3, or a 1, then a 4. So you pick any combination you want. You say, well, what if you rolled a 5, then a 2? Okay, you rolled a 5, and then a 2. It's right here. So it shows all of the results here. These are the numbers that you're concerned with in order to find the probability of something. So if we say, what is the probability of rolling a 4, then a 3? We would say the probability of rolling a 4 and a 3 right here. 4 then a 3 would be different than rolling a 4 and a 3, because if you rolled a 4 and a 3, it could go 3 and 4 right here as well. Anyway, a 4 then a 3 is only 1 out of 36. There's only one of them out of 36 options. If we said a 4, 4, 3, or a 3, 4, there's 4, 3, and there's the 3, 4. Now we have 2 ways that could go down out of 36 total. I'll do mathematical equations in lesson 2.